Okay, question five. Question five is the diagram shows a boat pulling a water ski. The arrow represents the force of the water produced by the engine propeller. The force causes the boat to move. Explain why. This one is a tricky one. This one always catches people out. It's to do with Newton's laws of motion. Remember, Newton has three laws of motion. And the third law, which is normally the one that people remember the most, and this is what this one is to do with, is that for every action there is an equal and opposite reaction. So in this case, we've got a boat, and the boat is pushing, pushing a force backwards on the water, but yet the boat is actually going forwards. So that's really, really odd concept. The force is going that way, backwards, but yet the boat is going forwards. So you need to be able to explain why this happens. And as I say, it's to do with Newton's third law of motion. So if we think about the force involved, so we can say the engine produces a force on the water. And remember, Newton's third law, for every action, there's an equal and opposite reaction. So the engine produces force on the water. The water produces an equal and opposite force on the boat. Now, the engine force was backwards, so the force that the water is acting on the boat is going to be in the opposite direction, it's going to be forward. So the engine produces a force on the water produces an equal and opposite force on the boat. This force is in the forwards direction, so the boat moves forwards, and obviously the water is pushed backwards. The boat accelerates at a constant rate in a straight line. This causes the velocity, of the water skier to increase from 4 to 16 meters per second in 8 seconds. Calculate the acceleration. So, box the thing we want. We want acceleration. Highlight the things we've got. So we've got a 4, we've got a 16, and we've got an 8. Let's figure out what they are. Dead easy with the 8. The 8 is time. It's in seconds. It's the standard units. There's no conversions there. And then we've got a change in velocity. So we've got a change in velocity. So we've got an initial velocity, initial V, and a final V here. So you've got a change in velocity. Remember, we used this symbol here. It means delta, change. So our change in velocity is 16.0 minus 4.0. So a change in velocity. Always use a calculator, even if it's dead easy. We should be able to do that in our heads, but let's not risk it in the exam. Let's not risk getting anything wrong. Minus 4.0 is 12. So we've got a change in velocity of 12.0 meters per second. We'll leave the calculator up for this one. So the boat accelerates at a constant rate in a straight line. This causes the velocity of the water skier to increase from 4 to 16, which is a difference of 12, in 8 seconds. Calculate the acceleration. So we've got to use the data sheet, and we're going to look for a form that's got acceleration, a change in velocity, and a time. Physics data sheet. Here's the one I used in the earlier question. Let's get rid of that. We're looking for an acceleration. So we can see acceleration here, acceleration here, acceleration here. Okay, let's check those. So we're looking for the other things we've got. So we've got a change in velocity and a time. This one, change in velocity and time. Acceleration equals change in velocity divided by time taken. So let's use FIFA. Formula. Acceleration equals a change in velocity divided by the time taken. Let's input our values. So acceleration, we don't know. change in velocity we do, which is 12.0, divided by the time it took, which is 8.0. 12.0 divided by, or over, 8.0 is equal to 1.5. Let's just check it. 12.0 over 8.0, and again we've got 1.5. So I'm going to trust that that's the answer. 1.5. Ooh, we have not got our units. So that's going to give us an extra mark. So the units of acceleration are meters per second squared. Very often people just write meters per second. But remember, it's meters per second squared. All right, next question. The water skier has a mass of 68 kilos. It's going to be another formula. Okay, so we'll label that as mass. Because this is a part 2 of the same question, we have to remember that we've got all of the data already from part 1 of this question. So we already know the change in velocity, we already know the time taken for that change, and we already know acceleration. We now also know the mass. So it wants to know the resultant force acting. So we've got a lot of information, so we're going to have to pick out a formula. We're going to have a formula that's got force, but then we've already armed with a time, we've got an acceleration. So let's jump to the data sheet. We're looking for one with force in. Let's get rid of what we were looking at earlier. Oops, scribble all over it. I just say we want a force and an acceleration. Resultant force, acceleration. Do we have a mass? Let's have a look. Do we have a mass? We do. Oh yeah, 68 kilograms. So yeah, it's going to be that formula. So F equals ma. Resultant force is equal to mass times acceleration. So the formula is F equals mass multiplied by acceleration. Input our values. So the force, that's what we're trying to find, is equal to 68 times by the acceleration, which we got from here. So 1.5. All right, we don't need to rearrange it, so there's no F, there's no fine tuning it. So the answer is going to be 68 times 1.5. Again, get the calculator. You could estimate in your head, it's going to be less than 68 times 2 and bigger than 68 times 1. So it's going to be a number between 68 and 136. So 68 times by 1.5 is 102. 102. And it's a force, so it's going to be newtons. So just write this in here. 102 newtons. Just check it. 68 multiplied by 1.5 equals 102. Okay, last question. Draw a ring around the correct answer to complete the sentence. The force from the boat pulling the water skis forward. Now, this is just the format in the way it's come up on my iPad. It would be different on an exam paper. The force from the boat pulling the water skier forward is less than, the same as, or greater than the answer, part B. And then give a reason. So look, so the force from the boat is going to be, the force from the boat is greater than, and that is, it's going to have to be greater than. It's going to be greater than, and the reason why is because the force needs to overcome the resistance forces. Yeah, the air resistance pulling it backwards. So force going forward, the water skier is getting faster. So therefore, the forward force must be bigger than the backwards force in order for them to accelerate. So the forwards force must be greater than the backwards force to over the water resistance. Okay, that is the end of that question.